Welcome to lesson 8-3, cube root functions. In this lesson, we are going to graph and transform and describe transformations of the cube root function y equals the cube root of x. We'll also identify some key features of a graph that models the relationship. So first, let's talk about the cube root of x. We'll be able to get a graph of f of x equals the cube root of x simply by making a table of values. Okay? So if we have an x and y table, we think about what numbers can go into a cube root. And we can actually put negative numbers into a cube root. So we'll start with -8 because it's a perfect cube. -1 is also a perfect cube. 0, 1, and 8. And those will be our main ordered pairs because they'll produce some nice answers. The cube root of -8 is -2. Cube root of -1 is -1. Cube root of 0 is 0. 1, 1, 8, and 2. And so we can get a nice picture of this cube root function, which just looks like the cube on its side. Okay, now what we want to do is take a look at this messier cube root function they gave us. Cube root of 3 divided by 4 pi x. And if we simplify 3 over 4 pi, we do get the cube root of 0.24x. And if we pull that to the front by rewriting this as a product, cube root of 0.24 times cube root of x, we can even simplify it further and make it 0.6 times the cube root of x. So it's just a multiplier. It's a times the cube root of x. And we also can see this as x to the 1/3 power, by the way, because a cube root can be written as a 1/3 power. So now we want to graph this in terms of using that stretch or that multiplication that we have. And so if we have f of x equals 0.6 times the cube root of x, and we already know how to graph the cube root of x, we just have to multiply those y values by 0.6. So -8, -2 would become -8, -1.2. And -1 times 0.6 is just -0.6. 0, 0 stays the same, and these will repeat, only they'll be positive. 8, 1.2. And so when you graph this, you can see the a value is what gives us a stretch or a shrink. And in this case, it's going to be a shrink. We're going to have a vertical shrink. We're going to get closer to the x-axis with this one. We don't rise quite as quickly as we did with the original function. So the graph looks a little bit like this, a little bit shrunk down to closer to the axis. So we're going to be using some transformations to help us graph if we know the parent function graph. Next, they ask us about domain and range of f of x and r of x. And if you look at these, there's no restrictions. There's no breaks in the graph at all, from -infinity to +infinity, and that'll be for both, -infinity to +infinity. All right, we're going to quickly review some transformations just to remember that what we have inside parentheses and outside parentheses make a difference on how we change our graph. So in part 1, we got j of x equals the quantity -2x cubed. So this is a cube function. That -2 inside the quantity, however, is going to mean we're going to have both a reflection and we're going to have a vertical stretch. The vertical stretch, though, if you think about that -2 as being raised to the 3rd power, that's really like having -8x to the 3rd power. So we're going to have a reflection with the negative, but we're also going to have a vertical stretch factor 8. The next one's a little simpler. It's just a x minus 5 quantity, so that's going to be a horizontal translation. That's going to be right 5 units. Okay. With m of x, it's outside the parentheses, so we are going to have a vertical translation. That's going to be down 4 units. Okay, and the last one has a bunch of different things happening with it. we're going to have, since we have a 0.5 inside the quantity there, we could think about factoring that out. It would have to have been multiplied by 3 and then times that 2 in front. So to get that stretch or shrink, we really have to think about that 0.5 being taken to the third power and also being multiplied by 2. So that would be 0.125, and then 0.125 times the 2 in front of it would give us a 0.25. So that would be our shrink. So we call that a vertical shrink, and the factor would be 0.25. Now we also have a +4 in the parentheses, so we're going to be going left 4 and down 6. That'll be our horizontal and our vertical translation. So on the next page, we're going to practice that with a couple of graphs. We have the graph of g of x, which is the cube root of -x plus 1 plus 3. We want to first talk about how it compares, and then we'll be able to actually make the graph using the transformations. So g of x and f of x are both going to have the same transformation, or g of x and j of x are going to have the same transformations. One's just a cube and one's a cube root. So we're going to list them here. Okay, so we're definitely going to have a horizontal translation, left 1. We're going to have a reflection over the y-axis, and we're going to have a vertical shift up 3. Now I reviewed the reflection rules on the side here in case you didn't remember those. You will have a shift over the y-axis if the minus sign is outside the quantity, like we have here. And not like we have here. And if the negative sign is inside the quantity, like we have here, that's going to be the reflection over the y-axis. So that's why we'll have that. Okay. So now let's go ahead and sketch our f of x again, because that is what we're going to start with. So our f of x is the cube root of x, which was -8, gave you -2, -1, -1, 0, 0, 1, 1, and 8, 2. So that's our cube root function. Now we have 3 things we have to do to every ordered pair in this function in order to get our new graph. So the first thing that we're going to want to do with our function is we're going to want to go to the left 1. Then we're going to want to reflect it over the y-axis, and then we're going to want to raise it up 3 units. Okay, so we'll do that with each ordered pair. Okay, so I'm going to go left 1, then I have to flip it over the axis, which will put it over here at +9, and then I have to go up 3. So we'll have an ordered pair up there. Now I've got my second ordered pair, and I'm going to go left 1, flip over the axis, and go up 1, 2, 3. Okay. Then the origin ordered pair, left 1, flip, 1, 2, 3, puts it up here. Okay, the one at 1, 1, I go left 1, flip, 1, 2, 3, puts it up here. And our very last one, we go left 1, that puts it at 7, flip, so it puts it at -7. And finally up 1, 2, 3. And here is our graph of the translated function, transformed function. Now, as we can see, the domain and range for each function, again, is going to be all real numbers or -infinity to +infinity. Okay, there's a couple more transformation questions down here that we can talk about. And for part A, in number 8, we have a negative outside the quantity. And so that's going to, of course, be a reflection over x. So we'll do reflect over x-axis. We have a -3 inside the quantity, so that is going to be a horizontal translation, and that's going to be to the right 3. Okay, in part B, let's just do the first one. We have a inside reflection, so that is going to be a reflect over y. And then we have a vertical translation. It's going to be down 1. And finally, we have a stretch factor 4. And because these are all cubes and cube roots, we are going to have domain and range of negative infinity to infinity. That's what's nice about the cube roots, no restrictions. So that will be it for this lesson. I'll do some of the practice and check your understanding with you in class. Have a great day.